Welcome, and in this episode, we're going to do some practice on applying F equals ma. Okay? Practice. So, in Newton's laws of motion, we need to be absolutely sure, absolutely certain of how to use F equals ma. Notice that the left-hand side is a net force, which I discussed before. This is the mass, and this is the acceleration. So, let's start with some examples. So I'll do some simple examples here, and then we'll do some more practical examples. I mean, more applied examples. So imagine I have a box. It's been subjected to forces like this. Imagine there's a force F here, this way, and there's a force F by 2 here, this way. And let's say that this angle is theta, and this is on a smooth surface. What is the acceleration of the block? That's my question. What is the acceleration? The block has some mass m. Well, what we're gonna do now is, since we have forces in 2 dimensions, it's best to resolve the forces. So I'm going to resolve the forces along the horizontal and the vertical. Let's see. Along the horizontal, how many forces do I have? I have one force here, that is F cos theta. I have one force here, that is F divided by 2. Along the vertical, I have a couple of forces. I have F sine theta. But not to forget, there is mg, and also not to forget there's an additional force, the contact force, that is a normal force, which is the weight, which we discussed in the previous episodes. And we know this guy is accelerating, and let's assume that the acceleration is this way. Okay, so what we're gonna do now is we're gonna apply Newton's second law. Net force equal to mass times acceleration in the horizontal separately, and in the vertical separately. Okay, so this is a net force. Some people like to put sigma over here just to indicate that's the net force. If you like that, then we'll use that as well, whatever. So how many forces? There are 2 forces in the horizontal direction. I've taken right side as positive, so F cos theta, which is positive, minus F by 2, that should be equal to, see, these are the only 2 forces which are acting on my block. There aren't any other forces. It should be equal to mass times the acceleration along the x direction. Therefore, acceleration along the x direction must be equal to, I can take the F common out, I get 2 cos theta minus 1 divided by 2 divided by n. Ta-da! There is my answer. Now, the direction of the Now the direction of the acceleration really depends on the value of theta. Notice that if the theta value is very small, for example, if theta is 0, then 2 minus cos 0 is just 1. So 2 minus 1 is 1. You get a positive number, and the whole thing would accelerate this way. That makes a lot of sense. On the other hand, if theta is very high, for example, theta is very close to, say, I don't know, maybe something like 90 degrees, very close to that, then you see this pretty much becomes a negative number because this tends to become 0. And now the acceleration will be in the opposite direction. So this also tells you you don't really have to know what direction the acceleration is. Just assume one particular direction and then solve, and if your answer is positive, your assumption is right. If the answer is negative, your assumption is wrong. That's it. Let's now do the same thing in the y direction. Okay? Now in the y direction, we have to be a little bit careful because there is gravity. Okay, now what happens in the y direction is, if this force F sine theta is high enough, then the object will accelerate upwards. If the force is not high enough, then clearly the object will not accelerate. So there are 2 conditions. So we'll now try and figure out. So what we'll do is, we'll first assume that the acceleration is 0. So if acceleration is 0, which will be the case in most cases. If acceleration is 0, then we can say the net force upwards is positive n plus F sine theta must be equal to, let's do it properly. Net force, which is n, which is positive, plus F sine theta, which is also positive, and there's a third force, minus mg. The reason there's a minus sign is because it's downwards and I chose upwards as positive. That must be equal to mass times the acceleration, which I've assumed to be 0. This is 0. Therefore, from this, you can see that n plus F sine theta must be equal to mg. Or I can also say n should be equal to mg minus F sine theta. So using this equation, we can actually figure out what the normal force is, even though the question is not asked. So let me just ask the question now. What is the normal force? Okay, so it becomes mg minus F sine theta. Now, how do we know whether, in general, this guy is going to get accelerated upwards or not? How do we know that? Well, think about it this way. As the F sine theta force increases, the upward component starts increasing. To keep the acceleration 0, net force must be 0, right? That means this total force, look at this. If the acceleration is 0, this force must be equal to this force. So as F sine theta increases, if this value increases, to make sure this equation is maintained, your normal force starts decreasing. You can look at this equation and understand that. Your normal force keeps decreasing. At one point, you see that the normal force becomes 0. And that is easy to understand. Normal force becomes 0 when this guy is equal to this guy. So let's just write that down somewhere over here. So n tends to becomes equal to 0 when F sine theta is equal to mg. Now, what if F sine theta becomes more than mg? Then normal force has to be negative, which means the normal force has to be in the opposite direction in order for this equation to hold good. But we know that normal force can't be in the opposite direction because the floor is pushing it up and floor can't pull it down. That's a clear indication, that's when this thing is going to take off. That means no longer these equations will be valid. And that's when AY cannot be 0. So in order for the object to accelerate, F sine theta, I hope you can see this. Yes, you can. That must be more than mg. If F sine theta is more than mg, then there will be acceleration in the y directions. So with this example, I hope you were able to understand how we can apply F equals ma in general. See you next time.